Good afternoon, folks. How's it going? This is Mike coming back at you with yet another video on Foundations of Math 2. In the previous video, we talked about measures of central tendency or measures of average, and we talked about finding the mean, median, mode, and mid-range. In this video, we're going to talk about measures of variation, specifically the range, the variance, and the standard deviation. What these measures tell us is how much does the data differ or vary between itself, and also how does it, or how much does it differ from the average. So the first measure of variation that we're going to get to is the range. The range of your data is simply the highest value minus the lowest value. And this is a very basic measure of variation. It's not really getting too depth in terms of what it's telling us, but it does give us a nice sort of basic overview of what is the difference between your largest and your smallest value. If there's a pretty big difference between your lowest and your highest value, then the data varies quite a bit. So there's going to be a lot of variation there. If there's not a big difference between your highest and your lowest value, then there's not much variation happening there. And perhaps that's what we want. So the range is simply highest value minus lowest value. That's all that is. The other two measures of variation are the variance and the standard deviation. And these things are heavily tied into each other. To find the variance and the standard deviation for a given data set, here's what we do. Here's the 6-step process. The first thing you're going to do is you're going to find the mean of that set of data that you're handed. Once you find the mean, you're going to subtract the mean from each value that is in your set of data. When you do this, you're going to come up with a whole bunch of differences. Pardon me. The English language is not happening with me right now. So in step 2, you're going to end up with a whole bunch of differences. You're going to take those differences into step 3, and what you're going to do is you're going to square each of those differences that you found in step 2. Now you have some numbers that are all positive or equal to 0. You're going to take those numbers and carry them forward into step 4. And in step 4, you're going to find the sum of those squares that you found in step 3. Once you have that sum, you're going to take that sum and you are going to divide it by n minus 1. And n is the number of data values that you had. So you're going to take that sum that you have, you are going to divide it by 1 less than the number of data values that you had. And this number that you get is going to be your variance. To get the standard deviation, you simply take the square root of your variance. So variance, you get first, take the square root of your variance, that gets you your standard deviation. And we're always working with the positive square root. So the positive square root of your variance is your standard deviation. Now, typically when we do these calculations, at least for our purposes, we're going to do this with, say, a sample from a population. So if we're doing these calculations with a data set that's a sample from a population, you'll sometimes see them called the sample variance and the sample standard deviation. As a formula, the sample variance can be symbolized by s squared, and that's equal to the sigma, or the sum. We saw this symbol in our previous video, of the squares of the differences between our x values, our values that we had in the data set. So the difference between the data value and the mean, and that sum divided by n minus 1. And then the sample standard deviation, we said to get the standard deviation, you take the square root of your variance. So this right here, s squared, is your variance. Take the square root of that. That's your sample standard deviation. So we're going to go through a couple sample problems where we find the range, the variance, and the standard deviation for some data sets. And because we're doing this by hand, we're not going to do this with too many pieces of data. If we had more pieces, we'd be using technology, and we'd be using calculators to help us figure that out. Okay, so here we have our first sample problem. Suppose we have 9 pieces of data below. We're going to find the range, the variance, and the standard deviation for this set of data. So the first one to find is the one that the first one that I suggest you find, yay dyslexia, is the range. It's really easy, a really basic calculation. You simply have to identify the largest and the smallest value in your data set, and then you take the difference. So the largest number in here is 61. The smallest value in here is 1. 61 minus 1 is 60. That's the range of this data set here. Next up, the variance. And we're going to be breaking out our calculator here as well so we can make some calculations easier for us. First thing we need to do is we need to find the mean. We need to find x bar. We need to find the average of these 9 numbers. So I'm going to add up all these numbers, and then I will divide by 9. So we have in here 61 plus 1 plus 1 plus 3 plus 2 plus 30 plus 18 plus 3 plus 7. That gives me a sum of 126. Divide that by 9. And we are going to come to 14. And anytime we can come to a mean that is a nice whole number, that is very handy. That makes our lives a whole lot easier, a whole lot nicer to work with. So this was step 1 in our 5/6 step process to find the variance and the standard deviation. Step 2, take each of these 9 data values and do data value minus the mean. So when we do that, I'll do this on the side here, and I'll do a couple of them, but not all of them. 61 minus 14 is going to give me 47. 1 minus 14 will give me negative 13. 1 minus 14 gives me negative 13 once again. And the other ones we're going to come up with are negative 11, negative 12, 16, 4, negative 11, and negative 7. If we do all the differences that we have to do in step 2. Okay, next step, I'm going to square each of these differences that I got. So 47 squared. Clearing that, 47 times 47. 2,209. Negative 13 squared is a positive 169. Negative 13 squared is a positive 169. Negative 11 squared is a positive 121. Negative 12 squared is a positive 144. 16 squared, if I recall correctly, is 256. Yep, 256. 4 squared is 16. Negative 11 squared is 121. And negative 7 squared is 49. So I just squared each of those values that I had. Next thing I have to do is I have to add up all of these values here in this column. So I have 2209 plus 169 plus 169 plus 121 plus 144 plus 256 plus 16 plus 121 plus 49. And this sum is 3,254. This is step 4 now that we've been through in our 6-step process. To find the variance, I need to take this number that I found and divide it by 1 less than the number of values I had. I had 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So subtract 1 from that. Obviously, that gives me 8. So I'm dividing 3,254 by 8. And when I do that calculation, that is going to give me 406.75. Okay, so that is our variance there. Now to get our standard deviation, and I'll write the variance here, 406.75. The standard deviation. Take the square root of that 406.75. 0.75. And if you do in your calculator, the square root of 406.75, let me get that 5 in there, 406.75. You get about 20.168. Obviously, the question would state round to a certain number of places, but we'll go 20.168. So there we go. That is our range, variance, and standard deviation for this data set. And note that the standard deviation and the variance are fairly large. I know that maybe you don't have a whole lot of context and real-world samples or just other cases of seeing these things to sort of make some kind of reference as to what's a large variance or a standard deviation or something like that. But just looking at the data ranging from 1 to 61, 20 is a fairly significant and fairly large standard deviation for a set of data like this. We're going to see how this can change in the next sample problem. So moving on to our second problem. we're going to do the exact same thing. We're going to find the range, the variance, and the standard deviation, but we're going to do it with the following data set below. We still have 9 values, but even once you find the range, you can probably guess what our variance and our standard deviation are going to be like. So the range, again, largest value minus smallest value. The largest value in this data set here is 78 minus the smallest value. I see a 68. 68 is the smallest value here. So 78 minus 68 is 10. So comparing the size of these values to the range, we have a fairly small range here. Our data values go between 68 and 78, and that's a small range given the size of numbers that we have here. So a small range means we should be seeing a smaller variance and a smaller standard deviation. So let's see if that does indeed turn out to be the case. We'll actually put the variance right next to it this time, not below and to the right of it. But first thing we need to do is we need to find the mean of these 9 numbers, or the average. So I'm going to have you do that right now on your own. Find the average of these 9 values. Once you have found the mean, press play and we'll continue on with the problem. Okay, so hopefully when you found the mean of your 9 numbers, hopefully you found that in your calculator you probably got 72.6666666667, basically 72 and 2/3. But for the sake of dealing with relatively nice numbers here, we're going to round it to 1 decimal place, and we'll say 72.7. So carry on, assuming that the mean is 72.7. Next thing I want you to do on your own is the next step in our process. Take each data value and subtract this mean from it, and record the differences that you get, of course rounding it to 1 decimal place. So pause the video here, do that. Once you come up with those differences, press play and we will continue on. All right, so hopefully when you came up with your differences, you came up with these values right here. You have your 9 differences. Next step, we're going to take each of these differences and we are going to square them. So press pause now, square each of these numbers and write down what those squares are. And while we're at it, then once you have each of those squares, add them up as well and get your sum. This will take care of steps 3 and 4 in our 6-step process. So press pause, square each of these numbers. You'll get some results, add up those results, and come up with your sum. Once you have that sum, press play, and we'll continue on. Okay, so these are all of the squares that you should have come up with. 5.3 squared is 28.09. Negative 0.07 squared is 0.49. Negative 4.7 squared is 22.09. And so on and so forth. And when you add up each of those, or when you add up all those squares, you come to 72.01. So to find the variance, I take this sum, 72.01, and I'm going to divide it by the number of data points that I had minus 1. So again, I had 9 pieces of data here, so I'm going to again subtract by, or not subtract, I will take this number and divide it by 8. And when you do that, rounding to, say, 3 decimal places, you get approximately 9.001. The question would specify, round to a certain number of decimal places. But that's your variance. To get your standard deviation, simply take the square root of your variance and so we see that it's not quite 3. We'll round to 4 decimal places here. You come to 3.0002. So this is our range, variance, and standard deviation for this problem. And the variance and the standard deviation did exactly what we thought they were going to do for this particular problem. We saw that there was a much smaller range between the largest and smallest values in this set of data here. So since we had a smaller range, we expected a smaller variance and thus a smaller standard deviation, which is exactly what happened compared to the previous problem, where we had a large range given the numbers that we had, and then we had a large variance and a large standard deviation. So that is how we find the range, the variance, and the standard deviation for a given set of data. So this concludes our video on measures of variation. If you have any questions or comments, please be sure to reach out to me, guys. Emails, texts, voicemails, phone calls, whatever, projectiles being launched at me, messages sent through cables, whatever. Until the next video, take it easy, guys.